Definition of similarity in triangle. Okay, so let us study what are similar triangles. Say I have two triangles. Say we have triangle ABC and another triangle DEF. Okay, so these two triangles are said to be similar if and only if the corresponding angles are equal. Okay, that is angle A is equals to angle D, angle B is equals to angle E, and angle C is equals to angle F. If these three conditions are true and the sides are proportional, that is AB upon DE is equals to AC upon DF is equals to BC upon EF. So you can see that the side AB is opposite to angle C and the side DE is opposite to angle F. Okay, so AB over DE to AC over DF and BC over EF. So these relations should be true. These angles should be equal and the sides should be proportional. If these two conditions are fulfilled, then we can say that the two triangles are similar. Similarity means they are same in shape, right? If you zoom in this triangle, then you will get this triangle. If you zoom out this triangle, then you will get this triangle. Okay, so by extending this triangle in a fixed proportion, then you can get this triangle. So this AB by DE, AC by DF, BC by EF, these are called scaling factor. Okay, so this is nothing but scaling factor. So the proportion by which you should zoom the triangle ABC to get the triangle DEF, that is scaling factor, you can say. So I think you know what you are clear about what is a similar triangle. So let us do an interesting property of similar triangles. So first let us study that under which conditions we can say that the triangles are similar. First one is that if all the three angles are equal in two triangles, then the triangles are similar, right? So say you have two triangles, say ABC and DEF. If angle A is equals to angle D, angle B is equals to angle E, angle C is equals to angle F. So if three angles are equal in both the triangles, then we can say that triangle ABC is similar to triangle DEF. So this is the notation for similarity. Okay, so this means similar to triangle DEF. Okay, now if say two angles are equal in two triangles, say I have given you that angle A is equals to angle D and angle B is equals to angle E, then can I say that these two triangles are similar? Yes, I can say so, because we know that the sum of angles in a triangle is 180 degrees. That is fixed, right? So angle C will be equal to 180 minus A minus B, and angle F will be equal to 180 minus D minus E, which will be equal because A is equals to D and B is equals to E. So automatically angle C will be equal to angle F. So instead of three angles, if only two angles are equal in two triangles, then also we can say that those two triangles are similar. Okay. Similarly, if three sides are proportional, okay, say in two triangles ABC and DEF, say we have AB over DE is equals to AC over DF is equals to BC over EF. If this condition is fulfilled, that is all the three sides are proportional, then also we can say that triangle ABC is similar to triangle DEF. And in this case, since the triangles are similar, then we can derive that the corresponding angles are equal, right? So the angle opposite to side AB is equal to the angle opposite to side DE. Okay, so this implies that angle C is equals to angle F, and this implies that angle B is equals to angle E, and this implies that angle A is equals to angle D. So the angles which are opposite to the sides, okay, they are equal. So if three sides are proportional in two triangles, then also we can say that those two triangles are similar. Similarly, if say two sides are proportional and the angle between those two sides is equal. Say I have two triangles ABC and DEF. Okay. Say if two sides are proportional, that is AB over DE is equals to AC over DF, and angle A is equals to angle D. Fine. So these two angles are equal, and AB over DE is equals to AC over DF. So the sides which are proportional contain these angles which are equal. So in this condition also I can say that triangle ABC is similar to triangle DEF. Okay, I hope this is clear to you. Fine. So let us once again quickly recap what we have learned. So we have studied that two triangles are similar if and only if all the three angles are equal and all the three sides are proportional. And we have noticed that if two angles are equal in two triangles, or if three sides are proportional, or if two sides are proportional and one angle is equal, the angle should be between those two sides. So then we can say that the triangles are similar. Okay, so let me give you a small question. So say that triangle ABC is similar to triangle DEF, and AB over DE is equals to say AC over DF is equals to BC over EF is equals to say 3 units. So now you need to find the area of triangle ABC to the area of triangle DEF. Okay. So just try this question for some minutes, then we'll discuss. So here the scale factor is given as 3. You need to find the ratio of areas of triangle ABC and DEF. If you get the answer, then let me know it in the chat. If you get the answer, let me know it in the chat. Okay, so let us discuss this problem. So we have two similar triangles, ABC and DEF, right? So this is ABC and this is DEF. Fine. So it is given that the scaling factor for these two triangles is 3. We need to find the ratio of area. I know that area of triangle ABC is half base BC times height. So let the height be AP and the height for this triangle be DQ. So it is half BC into AP over area of DEF is half times EQ times, sorry, it is EF times DQ. So we have wrote the formulas for areas. Now we know that BC by EF is 3, right? We know this one, but we don't know AB over DQ. We want to find AP over DQ. Okay. So if you observe the triangles APC, if you observe the triangle APC and triangle DQF, so these two triangles APC and DQF, okay, you can see that angle P is equals to angle Q, which is 90, right? And angle C is equals to angle F because these two triangles are similar. So these two angles should be equal, right? So now since two angles in the triangles are equal, since two angles in any two triangles are equal, then those two triangles are said to be similar, right? By the AA similarity criterion. So the triangle APC is similar to triangle DQF. So I can say that triangle APC is similar to triangle DQF. Now since these two triangles are similar, then I can say that the sides are proportional, right? So I can say that AP over DQ, right? AP over DQ is equals to AC over DF. So I can say half gets cancelled. BC over EF is 3 and AP over DQ is nothing but AC over DF. So which is again 3, right? So this is 9. Okay. So the ratio of areas is 9. In fact, in general, we can say that if two triangles, say ABC is similar to triangle DEF, okay, then I can say that the ratio of areas, the ratio of the areas of triangle ABC and triangle DEF is equal to square of the ratio of the sides. So it is AB over DE whole square, or you can write it as AC over DF whole square, or you can write it as BC over EF whole square. Okay, provided these angles are equal, right? Okay, this you can prove similarly by just dropping a perpendicular, fine. And if you write the formulas for A, this is half times BC and this as half times EF times DQ. So again, since the triangles APC and triangles DQF are similar, you can write AP over DQ, right? You can write AP over DQ as AC over DF. Okay, but AC over DF is nothing but BC over EF. So this is BC over EF whole square. Okay, so the ratio of areas of two similar triangles is equal to the square of the sides. Okay, so let's do another question. So say this is A, D, E, and F. So AB is given to me as 3, and BC is 4, CD is 5, AE is given as 5, and EF is given as 4. Fine. So we need to find the ratio of areas of triangle EBC to the area of triangle FCD. Right? So area of EBC to area of triangle FCD. You need to find this ratio. Okay, so give this problem a try, then we'll discuss. So you need to find area of triangle EBC to area of triangle FCD. So you need to find the areas of triangle EBC to area of triangle FGD. Okay, I'll give you an hint. You can try after that. So we already know the length of bases, right? We know the value of BC and we know the value of CD. So to find out the area, let us just draw the height. Okay. So draw perpendiculars from E onto BC and from F onto CD. Okay. Now try to find the ratio of heights by observing the similar triangles. Okay, some of you have already done. Let us discuss. So the area of triangle EBC to the area of triangle FCD, right? This is what we need to find. So what is the area of triangle EBC? It's half times base BC times height. So say this length height is h1 and this is h2. Okay, and area of FCD is half times CD times h2, right? Okay, so half get cancelled. BC value is given to us as 4 and the value of CD is 5. So it is 4h1 by 5h2. Now, if you observe the triangles, say this point is P and say this point is Q, okay? So triangle AEP is similar to triangle AFQ, right? These triangles are similar because two angles are equal, right? Angle A is equals to angle A because angle A is common to both the triangles and 90 degrees is also same. So in triangle AEP and in triangle AFQ, you can see that two angles are equal. So these triangles are similar, right? So these are similar by AA property. So then what can you tell about EP over FQ? That is H1 over H2. So this is nothing but AE over AF, right? So AE over AF is 5 over 9. So we'll just put on the values here. So value of AE is 5, value of AF is 9. So you'll get the answer as 4 over 9. Okay, is this clear? Okay, so let us move on. So another question. So ABCD is given to us as a parallelogram and P is midpoint of side CD. and BP meets AC at point X. So you need to find the value of AX over AC. Okay. So ABCD is a parallelogram and P is the midpoint of CD, and BP meets AC at X. You need to find the ratio of AX over AC. So first draw the figure and think about the problem. To draw the figure and try to observe the similar triangles. If you get the answer, then you can tell me in the chat. Okay, so let us discuss this problem. So there is a parallelogram ABCD, right? P is the midpoint of CD. So let us say this is P, and BP meets AC at X. So let us draw AC, and this is BP. So this point is X. Okay, you need to find AX over AC. Okay, fine. So since P is the midpoint, these two sides are equal, and since this is a parallelogram, I can say that DC is parallel to AB, right? Now, if DC is parallel to AB, then angle DCA should be equal to angle CAB, because these are alternate interior angles. So this angle is equal to this angle. Okay. And since PB and AC are straight lines, then angle AXB is equals to angle PXC, because these are vertically opposite angles. Okay. So angle AXB is equals to angle PXC, because of these are vertically opposite angles, and angle DCA is equals to angle CAB, because these are alternate interior angles, right? Now what can I say is these two triangles, that is the triangle AXB is similar to triangle XPC, because two angles are equal. So triangle AXB is similar to triangle PXC. Okay. So since these two triangles are similar, then we know that sides are proportional. Okay. So let us just use that formula for proportion of sides. So we need to find AX over AC. So let us first find AX over XC. Okay. So AX over XC would be AB over PC, right? And we know that AB is equal to CD, and CD is twice of PC. So this is 2. Fine. So AX over XC is 2, right? So then what about AX over AC? Okay, if AX over XC is 2, then X is K and AX is 2K. We can assume like this. So AX is 2K over AC is 3K. So this is nothing but 2 over 3. Okay. So AX over XC is 2 over 3. Okay, let us move on. So ABCD is a parallelogram, and X divides AB in ratio 3:2, and Y divides CD in the ratio 4:1. Okay. So if XY cuts AC at Z, then you need to find out the value of AZ over AC. Okay. So you need to find AZ over AC. So first draw the diagram and then think about the problem. Draw the diagram and think about the problem. So some of you have already solved the problem. Let us discuss. So ABCD is the parallelogram, right? So this is our parallelogram ABCD, and X divides AB in the ratio 3:2. So this is point X. This is the ratio 3:2, and Y divides CD in the ratio 4:1. So this is point Y, and this ratio is 4:1. Okay, and now XY cuts AC at point Z. We need to find AZ over AC. Fine. So let us try to observe the similar triangles formed here. Okay. So since the sides DC and AB are parallel, we can say that these two angles are equal. That is, angle DCA is equals to angle CAB, and these two angles are equal because these are the vertically opposite angles. That is, angle YZC is equals to angle AZX. Fine. So now I can say that these two triangles are similar. Okay. So triangle AZX is similar to triangle YZC. Fine. Now we need AZ over ZC, right? We need actually AZ over AC, but if we can find AZ over ZC, then we can also find AZ over AC. So AZ over ZC is nothing but equal to AX over YC, right? By the property of similarity of two triangles. Now what is this AX over YC? Okay, we need to find AX over YC. We can't say directly that AX over YC is 3:4, right? We can't say AX over YC is 3:4. Okay, so let us just repeat quickly what we have done. We have joined XY and AC, and we need to find AZ over ZC. Okay, because if we get AZ over ZC, then we can easily find AZ over AC. Fine. So we have tried to observe the similar triangles, and we found that these two triangles are similar. That is, the triangle AZX is similar to triangle YZC. So then I can write AZ over ZC is nothing but equal to AX over YC, right? Now, what I'm saying is we can't directly tell that AX over YC is 3/4, okay? Because AX over XB is 3/2, whereas CY over YD is 4/1, but we can't say that AX over YC is 3/4 directly. So we will have to find this AX over YC. So let us see how to find AX over YC. Fine, since AX over XB is 3/2, I can say that AX is 3x and XB is 2x. And since CY over YD is 4:1, I can say that YC is 4y and DY is y. Okay, so we have assumed the length of the sides as 3x, 2x and 4y and y. And now since ABCD is a parallelogram, I know that AB is equals to CD because ABCD is a parallelogram, so opposite sides are equal. And this gives me that phi x is equals to phi y. And so I can say that x is equals to y. So now I can say that AB over YC is nothing but 3x over 4y, which is nothing but 3/4. Okay. So this AX over YC is 3/4. So I have found that AZ over ZC is 3/4. Okay. So this is 3:4. Then you can clearly say that AZ over AC would be 3/7. Okay. So AZ over AC, this would be 3/3 plus 4, that is 3/7. Okay. So let's move on. Now what we are going to do is just consider a triangle ABC. Fine. And let us say AD is the angle bisector of angle A. Fine. So AD is angle bisector of angle A. Now we will prove that BD over DC is equal to AB over AC by the concept of similarity of triangles. We can prove this in many ways, but we'll use the concept of similarity here. Okay, that is, I mean to say that the angle bisector of angle A of triangle, okay, the angle bisector of angle A will divide the opposite side, okay, in the ratio of the length of its adjacent sides. Fine. So the angle bisector AD will divide the side BC in the ratio of the lengths of adjacent sides. That is, BD over DC would be AB over AC if AD is the angle bisector. Fine. So that we are going to prove here. Okay. So this is we need to prove. So this, you can say that this is called internal angle bisector theorem. Okay, this is called internal angle bisector here because we are drawing the internal angle bisector of angle A, and we need to find the ratio in which this angle bisector divides the side BC. So what I am doing is I am extending AD. Okay, I have extended AD, and I am drawing a line parallel through a line passing through C, which is parallel to AB. Okay, so what we are doing is we are extending AD and we are drawing a line through C which is parallel to AB. Okay, say it cuts this AD extended at point E. Okay, so cutting AD extended at point E. Okay, now let us try to observe the similar triangles in the given figure. So angle ABD is equals to angle DAC because AD is the angle bisector, and if you see that the lines BA and EC are parallel and AE is the transversal, right? So this angle would be equal to this angle because these are alternate interior angles. So angle DEC is equals to angle BAD because these are alternate interior angles. Similarly, these two angles are equal because these are vertically opposite angles. So angle EDC is equals to angle ADB because these are vertically opposite angles. Now, if you observe these two triangles, that is the triangle DCE and triangle DAB, you will find that two angles are equal in these two triangles. So these two triangles are similar triangles. Fine. So we can say that triangle ABD is similar to the triangle DCE, right? By AA similarity criterion. That is, the two angles are equal. Fine. So we need to find the ratio BD by DC, right? We need to prove that the BD by DC is equal to AB by AC. So let us use the proportionality of sides. So BD over DC, okay, BD over DC, that is BD is opposite to this angle and DC is also opposite to the angle which is equal to this one. So BD over DC would be equal to AB over CE, right? So this is AB over CE. Okay. But we need to prove that BD over DC is equal to AB over AC. Okay. So we need to prove that AC is equals to CE. Fine. Now if you observe this triangle ACE, okay, since these two angles are equal, I can say that the sides opposite to these angles are also equal. So I can say that AC is equals to CE because these two angles are equal. Okay. So this I can write it as AB over AC because CE is equals to AC. So what we have done here is that we have proved that BD over DC is equals to AB over AC. So in any triangle ABC, the internal angle bisector, right? The internal angle bisector will divide the opposite side in the ratio of length of adjacent sides. That is, BD over DC would be equal to AB over AC. Okay. Fine. And the converse is also true, right? What is the converse? Converse is nothing but, say you are given a triangle ABC, okay, and say you are given a line segment AD such that BD over DC is equals to AB over AC. Okay, if this is given to you, then you can say that AD is the angle bisector of angle A. AD is the angle bisector of angle A. Okay, so that means that these two angles are equal. So I will leave this as an exercise to prove it. Okay, so this you can prove at your home. Okay, so now say you are given a triangle ABC. Okay, so AD is the angle bisector of angle A, and the length of sides are denoted by small letters. That is, AB is denoted by small c, AC is denoted by small b, and BC is denoted by small a. Fine. So you need to find the length of BD in terms of small ABC, and you need to find the length of DC. Okay. So do this question and then we'll discuss. You need to find BD and DC in terms of small a, small b, and small c. It is given that AD is the angle bisector. Okay. So we know that BD over DC is equals to AB over AC by the internal angle bisector theorem. So BD over DC is nothing but C is to B, right? So this is C is to B, and this entire length is A, right? So what will be BD? This will be C by C plus B into A, and DC would be B by C plus B into A, because this entire length A you need to divide into two parts of the ratio C to B. So what you do is, first you divide this length A into C plus B equal parts. Okay. So we have divided length A into C plus B equal parts. We have got A over C plus B. And out of those C plus B parts, we are giving C parts to BD and B parts to DC. That is how we have written this. That is C times A by C plus B and B by C plus B into A. Okay, good. So say we are given a triangle ABC, fine, and say AD is the angle bisector and I is the incenter of the triangle. Okay, so AD is angle bisector and I is incenter of the triangle. Fine. So you need to find the ratio AI over ID. Okay, in terms of ABC. So that is AB is equals to C, AC is equals to B, and BC is equals to A. So you need to find AI over ID in terms of ABC. Okay, I'm repeating this sum. We are given a triangle ABC and AD is the angle bisector and I is given to us as the incenter of triangle ABC. So you need to find the ratio of AI over ID in terms of the sides ABC of triangle. So if you can get the answer, then tell me in the chat. Okay, so let us discuss this problem. What I'm doing is I'm joining BE. Sorry, I'm joining BI. So if I join BI, since I is the incenter, then BI should be the angle bisector, right? Since I is incenter of the triangle, what is incenter? It is nothing but the point of concurrence of angle bisectors, right? So the angle bisector of B will pass through incenter. So this implies that BI is the angle bisector of angle B. Okay. Now, if you observe this triangle, that is the triangle ABD, you can see that BI is the angle bisector of angle B, right? So since BI is the angle bisector of angle B, I can say that AI by ID will be equal to AB by BD, right? So in triangle ABD, since BI is the angle bisector of angle B, then the angle bisector divides the side AD, that is AI over ID, in the ratio of its adjacent sides, right? So it is AB over BD. Okay, so the length of AB is small c, whereas the length of BD we have found in the previous problem, right? That is the length of BD is CA by C plus B. So this is CA by C plus B. Okay, so this is nothing but B plus C by A. So AI is to ID is nothing but B plus C is to A. Okay, so AI by ID is B plus C by A. Okay, fine. So we'll end this session